Hello friends. So today now we are going to look into another type of searching, right, which is called as exhaustive search. So there is a concept, what do you mean by an exhaustive search? So in the previous class we have seen the brute force technique. Now brute force technique or brute force approach used to solve a special type of a problems, that is a problem which consists of like say a permutation and combination, or you can say combinations of both type of problem, permutation and combination problems, which is called as combinatorial problems. So for these, to solve these combinatorial problems, when you apply the brute force technique, now we call it as an exhaustive search, right? So brute force approach used to solve a combinatorial problems is called as an exhaustive search. Now the solutions to such type of a problems, like as we are telling, now the problems can be a permutation problems, or it can be a combination problems, or say for example we have got a subset of sets, etc. Now these type of problems take lot of time, it consumes more number of time, right? So because the problem itself is in a recursive manner and it takes lot of time. Now this searching technique, now what we are trying to discuss here, exhaustive search, so it generates all possible solution by satisfying the constraints. Now what do you mean by the constraints here? Now all such type of problems has got some constraints, hurdles, certain we can say that rules. Okay, so we have got some constraints. Now if you want to solve that problem, so we have to look into the constraints, and it has to satisfy, the solution has to satisfy the constraints also. So the searching technique, what we are going to apply here, or what is called as the exhaustive search, now it generates all the possible solutions by satisfying the constraints of the given problem, and finally we get a desired solution. Now the solutions of this type of problems, it can be either maximize or it can be minimize problem. Now it will be either maximization. Say for example, now you want to maximize a profit. So if you go to any organization, what is the main thing what they want? They want to maximize the profit. How can they maximize the profit? By minimizing the resources or by minimizing the expenses, right? Now we see that all these type of problems will be either maximization or a minimization problems. So the goal of exhaustive search method, so what is the main goal of this exhaustive search method, is to search all the possible solutions. Now you are going to search now all the possible solutions and obtain an optimal solution, right? Now we are going to obtain an optimal solution. So which is the optimal solution? By looking or by searching all the possible solutions. So to understand the exhaustive search, now we are going to look into three important type of problems here. So we try to understand three type of a problem. The first one is called as the travel salesman problem. Next we will be discussing knapsack problem, and the third one is the assignment problem. So first, now we will start with the travel salesman problem. So it's also called as TSP. Now what is this travel salesman problem? So now the problem says that there is a salesman. Now he has to travel some cities. Let us assume that he has to travel 5 cities, right? Now we will give the name for the city as A, B, C, D and E. So you have 5 cities are there. Now the salesman has to travel all the cities. Now there is a constraint, as I told that all these type of problems have got some constraints. Now what is the constraint given for travel salesman problem is that now the salesman has to travel, he has to start from a starting city. Let us assume that he is starting from A. Now he has to travel all the cities and comes back to A. He has to come back to the city from where he has started. And the constraint is that he has to visit all the cities exactly once. Now he cannot visit more than once. So he can go. So he is starting from A. Now from A he can go to B, or he can go to C, or he can go to D. Any way he can travel, but ultimately he has to visit all the other cities exactly once and come back to the city from where he has started. So this is the the travel salesman problem, or you can say how we are going to define the travel salesman problem. Now if you look into this travel salesman problem, now with respect to our graph theory, it is nothing but finding a shortest path in our Hamiltonian circuit. Now we have got some type of a circuit or of a weighted graph, now which is called as Hamiltonian circuit. So finding the shortest path in an Hamiltonian circuit, now it is nothing but travel salesman problem. So if you try to understand, or if you try to look into this travel salesman problem, now it is similar to the kind of a problem now which is been discussed in our graph theory, which is called as a finding the shortest Hamiltonian circuit of a weighted graph, right? So now let us try to understand now how we are going to solve this particular travel salesman problem. So now, as we have stated that now the problem consists of 5 cities. Okay, so Hamiltonian circuit. So as we said that travel salesman problem is similar to a Hamiltonian circuit, finding the shortest path of an Hamiltonian circuit. Now let us understand how do you define a Hamiltonian circuit. Now a Hamiltonian circuit is a sequence of n plus 1 vertices, right? So we have already defined in our previous class what is a graph. Now graph is nothing but a tuple which consists of set of all vertices v and set of all edges e, right? Now a Hamiltonian circuit is nothing but a sequence of n plus 1 vertices which can be named as v0, v1, v2, etc., vn and v0. Now you can see here you are starting from a vertex v0, right? The salesman is traveling from a city A and he has to come back to the same city. So you are going to start with vertex v0, starting vertex. Now you have to end with the same vertex v0. Now that is why we say that it is a sequence of n plus 1 vertices, where the first and the last vertices of our sequence is the same, right? So he is going to start from the same vertex and he is going to end with the same vertex. Now such a type of a sequence is called as a Hamiltonian circuit. So now using exhaustive search, now we will try to solve this travel salesman problem. Now you can see here, now below a travel salesman problem is been given and it is been represented in terms of a graph. Now you can say that this is a graph and weights are given on this particular graph. Now it has got some set of vertices. Now what are the vertices given in this graph? Now in this graph the set of all vertices are A, B, C and D, right? Now the 5 vertices are given in this particular graph, A, B, C and okay. So this is the travel salesman problem. Now cities are given. What are these cities? Now these cities are labeled as A, B, C, D. So 4 cities are there. Now the salesman has to travel from city A. Now he is going to start with the city A. The first city is A. So then now he has to travel all the cities, that is B, C and D, and comes back to A. But when he is coming back to A, now he has to take care that what is the constraint what we have defined. Now all the cities has to be traveled exactly once. Now he has to travel all the cities exactly once. So now we will write all the possible routes, right? Now we will try to do the searching here, that is exhaustive search. Now what it says, get all the possible solutions. So first make a list of all possible routes available for him, then find the optimal solution. So what is the optimal solution here? What he wants, the salesman, when he is traversing all these 4 cities, now from each city, like say for example, if you look here, from city A to city B, now distance is given. So this vertex edges are been given some weights. Now this weights, like say from city A to city B, it is 3 kilometers. Let us assume for example, now all these weights are in kilometer, Now, if he goes from city A to B, now he has to travel 3 kilometers. Like this, similarly, respectively, or from each city to another city, the distance is given. Now, you have to find the total distance. You have to find the total distance starting from city A, visiting all the cities exactly once, and coming back to A. Now, what is the total distance you calculate? Now find all the possible solution or all the possible routes. Then when you list down all the distances, which one is optimal? Because the salesman has to search the shortest path. He need not unnecessarily travel or select a path whose distance is more. Right? That is the major aim or the solution of this particular problem. So we will list down now all the path. Let's say for example, if you take the first path here, now what he is doing, now he starts from city A. So from A he goes to B. So from A he goes to B. What is the total distance? Total distance is 3. So from B, now either he can go to D or C, right? Now we will first select from B, he goes to city C. So from B he goes to city C. What is the distance? 5. So 5 plus 3. So total is 8, right? Now yes, the total distance still coming to city C is 5 plus 3, 8. Now from C, now he goes to D and the distance is 1. So 8 plus 1, 9, right? So now the total distance is 9. Now from D, now he comes back to A from where he has started, and this distance from D to A is 4. So 9 plus 4 is 13. So the total distance here what we got is 13. So this is how we find the total distance. Now this is one possible route. There can be so many other routes. Now let us take the second route which is available. Now we write down the second route we are going to write down. Now in the second path, how is it? Now he starts with A, right? Now he starts with A, then goes to B. Find out from A to B what is the distance. The distance is from A to B, the distance is 3 kilometers. So then from B he goes to D, right? From B to D the distance is 9. So what is the distance? You write on the distance here. The total distance is 9 from B to D. And from D to C the distance is 1, and from C back to A the distance is 7, right? So distance is 7. So 9. Now you add all this, so you will get the total distance, right? So 9 plus 1 is 10, and 7 plus 3 is 10, plus 10 is 20. So the total distance he got is 20. So like this you write down all the possible routes for this particular problem. So totally we have 3, 4, 5, 6. So we have 6 routes are available for us, and find out all the total distances. So all the distances for each route are been written here. Now once you have generated all the possible routes from city A to traversing all the cities and coming back to A, right? Now these are all the possible routes. Now once you write down all the routes and find the total distance, now you have to select the optimal. Now which route is best for us, or which route is best for the travel person, right? Or the salesman, so who is traversing. Now which route is best for us? Now if you look here, now there is 2 routes are available with the distances 13. I can see here the first route, the total distance we are going to get is 13, and the third route also total distance we are going to get is 13. So we can say that now if he selects either of these two, because the distance is very less, the distance is 13, we have got 2 routes with the shortest distance, right? Now whereas if you take some other route, the distance is more for us. So why to unnecessarily the salesman has to travel or select a route whose distance is very large, correct? So optimal. Now if you look here, now there are 2 routes are available for us. The first route, that is A to B, B to C, C to D, and D back to A. So that is an optimal route, because the total distance what he got is just 13 kilometers. Similarly the third route that is from A to city D, and from D to C, and C to B, and B back to A, also gives us the distance. So now Hence we can say that so the salesman can opt any of these two routes. So which are the two routes which is giving him the less values, or we can say the total distance is less. Now he is going to select those two routes. So now those two routes will be the optimal route for that particular person. Now this is how now we try to search, right, the entire the travel salesman problem. So now if you look here, when you do the analysis of here, now here we are generating n minus 1 permutation. So n minus 1 permutation are the routes we are going to do it. So now you see that. So what was the n value? How many cities was given for us? So 4 cities was there, right? So there were totally 4 cities for there. Now n minus 1 permutation, that means 4 minus 1, that is 3. So 3 permutations. So 3 permutation means totally 6. So 3 permutations, right? So 3 permutations means, so how much we will get? So 3 permutations, so 3 into 2 into 1, right? So the formula for permutation, you know that. So 3 into 2 into 1 is 6. Totally 6 routes are available for us if you have got 4 cities. Now you can use this, the generalized one. So we say that if you have n cities, then totally n minus 1 permutations or routes is available for us. So now if you calculate the time complexity, so the time complexity of travel salesman problem is in the order of n minus 1 permutation. So it is in the order of n minus 1 permutation. So thus we can say the time complexity belongs to theta of n minus 1 permutation. Right? So this is the first the problem what we have discussed under the exhaustive search. So I think it is clear now. Okay, so what we did is that we took our problem, what was our constraint there? He has to travel all the cities exactly once. That was the first one. The second constraint is from the city from where he has started, he has to come back to the same city. Now by satisfying these two constraints, generate all the possible routes and find the total distance for each route, and once you get the total distance out of all those, which is the path or the route which is giving me the smallest distance, because it is obvious that when you are traveling, say for example you are traveling from your college to your home, always you will select a route which is very nearer, whose distance is very less. We don't want to unnecessarily go round and select a path which is very far, right, whose distance is more. That is what the first problem we have defined. The second interesting problem which we are going to discuss in exhaustive search is called as the knapsack problem. Now what does this knapsack? Now knapsack means it is just a bag. Okay, just assume a bag. So now how does we try to define this problem? Now given a knapsack, right? So we are given a bag. So now let us say that now you are having a bag. You go for a shopping. Now when you are going for a shopping, now you try to take a bag. Now whose capacity is W, right? Now whose capacity is W. So that means in this bag, now you can fill only so many items because the weight is given. So the capacity of the bag is given. Like say that you are carrying a bag in which you can just put some 10 kgs, any items, right? Or say for example, now a person is going to rob a particular home. Now before he goes for a robbery, now he is carrying one bag with him, so that when he goes inside, now he has to rob some items, put that in the bag and carry that bag outside, correct? Now he is carrying a bag. So what is this bag capacity? The bag capacity is W. So we write it as W. Now there are n items. Now when he goes for robbery into a house, so now there are so many items in front of him which he can steal and put that in the bag. So there are n items of weights. Now all the individual items which he wants to steal, now every item has got some weights, right? So the weights are indicated as W1, W2, etc. up to Wn. Right, so the capacity of this knapsack is given and there are n items. Now each item weight is given for us, W1, W2, etc. up to Wn, and value or profit. Now there is a value given, or you can say profit. That is, now for all these weight, for W1, say for example he wants to steal one particular item. Now if he steals that item from the home, now that item has got some weight, plus if he sells that item outside in black market, if he is going to sell that item, how much profit he is going to get. So for this particular item 1 whose weight is W1, profit is V1, right? So the value or profit is given. For the second item W whose weight is W2, what is the profit is going to make? V2. So like that, so V1, V2, etc. up to Vn, right? So the profit for all these items I1 to In is been given for us. Now what is given, right, in this problem? First is you are taking a bag, that is a knapsack. The weight of this knapsack, capacity of this knapsack is given W. That means in that particular big bag, now you can put all the items in this particular bag, but how much you can put? The only total weight should be W, not more than that, because if you put more weight you cannot carry, you cannot put this in the bag. The limitations is given for us, right? One of the constraints. Next, what is given is that every item's weight is given, and for each item weight, for each this item, so a profit is been given. Now what is our problem says that now we have to find the most valuable subset. We have to find the most valuable subset of the item that fits into the knapsack, right? Now when he is going to steal, now he has to steal those items which gives him more profit, because later if he sells it outside, now the item should give him some profit. So such a type of items he is supposed to select, right? So now we try to formulate this particular problem. So now what is our problem says? Maximize, right? Now we want to maximize what? Maximize the profit. So we can write maximize summation for I is equal to 1 to n. So what is this I? I is the weights. You have so many weights are there, right? So many items are there, I1, I2, I3, etc. up to In, right? Now you are going to pick all these items, but how you are going to pick? Based on the profit, right? So you should get a maximum profit. So maximum summation I is equal to 1 to n Vi into I1. So Vi is what? Vi is the value or the profit associated, and capital I is the item, right? So for I is equal to 1, that means for first item how much is the profit, plus if you select second item how much is the profit. Profits are given for us. Similarly, if you select fourth item, how much is the profit, right? So you are going to maximize the profit subjected to the constraint. Now the constraint is given for us. What is that particular constraint given for us? The constraint says that when you find the summation of weight, so summation for I is equal to 1 to n Wi into I for individual item. So if you take the first item, how much is the weight of the first item? You have to find. If you are taking next, selecting the third item, what is the weight of the third item? When you do the summation, you will get some total weight, right? Say for example, in front of you, there are 3 items present. So you have to pick these 3 items. So 3 items are there for us, in front of us, I1, I2, I3. Now out of these 3 items, you should select in such a way that when you find the total weight of all these items, it should be less than this W, because this is the maximum capacity of our bag. You can't put more than that particular capacity. So what is our constraint says that summation for I is equal to 1 to n Wi into I, capital I. That means for individual weight. When you find this summation, always this should be less than the capacity of our knapsack W. So it should be less than our capacity of the knapsack, right? Now this is how you are going to define a knapsack problem. So knapsack problem is a maximization problem. Now if you go to the previous problem, travel salesman problem, it was minimization, because there we wanted to find a route which is minimum, whereas here we want to select the items which gives you the maximum profit. Once you sell it outside, you have to get more profit, so we call it as maximization. So this is the maximization profit, subjected to the constraint that when you are picking the items, you have to take care that the total sum of all these items should be less than your knapsack, right? Now let us see that now how we are going to solve this by the exhaustive search. Now let us take a simple problem. Now here in this problem, now there are 3 items given for us, right? So take this problem. So what is this problem say that now there are 3 items. So what is these items? Now items are been denoted as A, B and C. Now we have 3 items are given for us, A, B and C. Now their weights are given. Now weight is also given for us. So for A, what is the weight? For B, what is the weight? And for C, what is the weight for us? So item A weight is 18 kg. Let us assume item A weight is 18 kg. Now item B weight is 8 kg and item C the weight is 3 kg. Sorry 22 kg. So for 3 items weights are given. Let their values, profit is also given. So profits are 41, 28 and 50 respectively. So that means for item A weight is 18 and the profit is 41, and for item B weight is 8, profit is 28, and item C weight is 22, profit is 50. And also what is given? The capacity of this knapsack, right? The capacity of this knapsack W is 30 kg. That means you are taking a bag of 30 kg. That means you can put items in this bag. How much you can put? Only till it reaches 30 kg or less than that. More than 30 kg you cannot carry in that bag. So that is the constraint. You have to see that always which items you are going to select. You select the items in such a way that you should get maximum profit plus the weight should be less than the capacity of our knapsack. Now this is how the problem we are going to solve. Now we have to find the subset. Now what? Now when you take this set which consists of 3 element ABC, you have to find the subset of these elements so that the total weight can be at most 30 kg, right? So the weight, the items, you have to keep on finding the right all the subset. The maximum weight it should be 30, not more than that, and the total value to be selected. Which items you are going to select? When you select each item, you have to find the weight value and find the total, and that total should be maximum, right? So now we start with an exhaustive search. Now this exhaustive search technique to this problem, what it says, you pick all possible subset of a given set. Now keep on writing all the possible subset. Now you start. So you know that in mathematics, now how you are going to create a subset, right? So let us say that I think this it's not clearly visible, but anyhow now it's very simple. Okay, now we will write here subsets. So we try to design write one table here. Now the first you are going to start with subset. What is the total weight, right? So for each item some weight is been given, and what is the total profit, and we will write down feasible, yes or no. Is it feasible for us? Does it satisfy the constraint all us? So first we start with an empty set, right? Empty set is also a subset. So you have set A, B, C, 3 elements in a set. So we start with an empty set. Now empty set means you are not selected any element. If you are not selected any element, what will be the total weight? Total weight is 0. So what is the value? Since you are not selected any weight, so the value will be 0. Is it feasible? Does it satisfy the constraint? Yes, because, right? Is it satisfy the constraint? Weight is less than 30 kg. The total capacity of knapsack was 30 kg. So we will write feasible, yes. So next subset we are going to select. Now you select only one item A, right? Now you are going to select only one item A. So we keep on writing the subset. So first subset will be an empty set, right? So after that empty set, now you will be having you'll take the first element A, right? Then you will take another element B, then you will take another element C, is also a subset. Then AB is a subset, AC is a subset, BC is a subset, and ABC is a subset, right? So like this you write down all the subset, generate all the subset of this set A, B and C as an element. So second time you take only one element A. Now what is the total weight of A? So for item A, weight is 18 and profit is 41. So you write down under this total weight 18. So weight is 18. Now what is the profit for that particular weight? That is for that item A, profit is 41. Right? So profit is 41. Now you see that is it feasible or not? What is the total weight of this item A? 18. And your capacity, knapsack capacity, what was your knapsack capacity weight? Now it was 30. So W was given as 30. Right? So not more than 30. So you cannot take an item which is more than 30. So now when you select the item A, weight is 18, so total value what you are going to get is 41. Now since the weight is less than, right, this 30 capacity of our knapsack, so this is feasible for us. Now it is feasible for us, right? Next you take the next subset. Now B is a subset. Yes, B is a subset. Now when you take the second item B, what is the total weight for the second item? Given for us, total weight for second item is 8. So we will write it 8 here. Now the 8 is the total weight for your second item. And what is the value for the second item? It is 28. So the value for the second item is 28. Now you check is it feasible or not. So this is also feasible because the total weight is 8, which is less than 30. So you can select that particular item also. How much profit you are going to get? 28. Next, go to the next subset C. So C is again a subset. Third item, what is its weight? 22, and the total value for this particular weight is 50. Right? So the total value for this weight is 50. Now again if you check here, 22 is less than 30, so this is also feasible for us, right? So now we started with empty subset, we are generating. See how you get this is just simple mathematics. You are having a set of A, B, C, 3 elements in the set are there, you generate all the subset. So you start with an empty set is a subset, then only one element A is a subset, B is a subset, C is a subset. Now you take combination. So next, now you will select 2 items A and B. Now you will see is it feasible or not. Now how many elements you are selecting? 2 elements A and B. So weight. Now what is the weight of the first element A? Weight is 18. Right? You are selecting 2 items A and B. So A's weight is 18. Second element B's weight is 8. So what is the total weight now? 18 plus 8, which is 26. So you are going to get the total weight is 26. Now similarly find the profit. Now what is the profit for first item A? The profit is 41, and for second item B the profit is 28. Now when you add both of this, 41 plus 28, you get 69. So total profit is 69. Now you are going to check, now is it feasible for us or not. How do you check whether it is feasible for us or not? You look into your weight constraint. The total weight, when you selected 2 items A and B, what was the total weight we got? The total weight was 26, and 26 is less than 30, right? It is less than 30. So we can say that this is feasible. You can go ahead with this combination. You can select item A and B also. Now you will select another combination A and C. Now we'll go for A and C. Same process we are doing. So for A, now what is the total weight? Total weight for A is 18, and for C, third item C, the weight is 22. So when you find the sum, so 22 plus 18, so you get 40. Right? The total weight will be 40 of these 2 items if you select, and the profit will be 41 plus 50, 91. Now is it feasible? Now when you look into the weight, the profit, so profit you are getting 91. So you will be saying, oh, we got highest profit, we got 91, right? The profit is 91, but it is not feasible. Why? Because if you look into the weight, when you select the item A and C, when you find the total weight of both these items, the total weight becomes 40 kg, right? The weight of these two items is 40 kg, but what is your capacity of Knapsack? It is 30 kg. You have got a bag of only 30 kg. Now how can you put a two items whose weight is 40 kg in this 30 kg bag? It does not fit us, right? So here we say that this is not feasible for us. So not feasible means you cannot select item A and C, because when you select A and C, even though profit is 91, but the weight of these two items becomes 40, which is greater than 30, so you cannot select these two items, right? Now similarly, the next subset is B and C. So this is B, okay, this is B and this is C. Now you select these two items B and C and do the same process. So you will come to know that it is feasible. Now if you select all the three items, you have only three items. If you are selecting all the three items, and when you find the total weight of all three items comes to be 48, and you know that 48 is greater than the capacity of this knapsack. Now you cannot even select all the items, right? So now this is the table which we have written. Now what is our problem? Maximum profit. Now you have to get maximum profit, right? When you are selecting all the items, now you have to get a maximum profit out of this. Now you look all this column, which all the combinations are feasible for us. And so the first one, null subset or empty subset, it was feasible. The second, only item A is feasible, only item B is feasible, item C is feasible. Now simultaneously keep on checking the profit now, because we want maximum profit, right? If you don't select anything, what is the profit? 0. It is waste, right? You like, say for example, the robber enters the home, right? Successfully he enters the home and comes outside the home without stealing anything. Then what is the use of going inside the home, right? So profit is 0. So you leave this. Now if you select the only one element A, if you pick only one element A, profit is 41. That is first element. If you pick second element, profit is 28. You can leave this because 41 is greater than 28, right? If you select A, you get more profit, 41. Now if you select only B, you will get profit is 50. Now you can leave this 41 because C is giving you more profit, correct? Isn't it? Now if you select A and B, profit is 69, right? Profit is 69. Next combination which is available for us is B and C. So if you select AB, you get profit of 69. If you select BC, you get profit of 78. Now you can see that 78 is giving you the maximum profit of all these combinations, right? Of all these combinations. So that is why, so now what is the optimal solution? So which items if you select, you are going to get a maximum profit plus the constraint is been satisfied. So that is item B and C. Now this item B and C is the one which gives you the maximum value or maximum profit. So you are going to select the items B and C. All the other items if you select, either the profit will be less or the weight will be more than the capacity of this knapsack. So the optimal solution for this particular problem of knapsack using exhaustive search. So why we call exhaustive search is that you are generating all the subset. So if we have taken a simple example of 3 elements, right? So we got so many, right? 1, 2, 3, 4, 5, 6, 7, 8. So totally we got 8 subset by selecting only 3 elements, isn't it? So if you have more number of elements, then you have to keep on writing all the subsets, then calculate for each subset what is the total weight and look into the constraint and finally come to the optimal solution. That is why we told exhaustive search takes lot of time for us. So it takes lot of time. So we have some other analysis techniques is available which is better than the exhaustive search, right? So for any knapsack problem with n items, then we have to find out all possible subsets. So how do you find the possible subsets? It is 2 raised to the power of n. Now if you have n set, that is if you have got a set with n elements, then the total number of subset which you can generate from that is 2 raised to the power of n, right? 2 raised to the power of n. So here we had an element of n is equal to 3 items, so 2 to the power of 3. So that many subset here we have generated. So we can say that the time complexity of this algorithm will be equal to 2 raised to the power of n. 2 raised to the power of n. So it takes huge amount of time as n increases, right? If you have got 10 items in front of you, if you want to pick up, then 2 raised to the power of 10 subset you have to write first. Generate all the subset, and for each subset look into the weights and check the constraints and what is the profit you are going to get, and finally find the optimal solution. So it takes huge amount of time. That is 2 raised to the power of n. Clear? So this is the second problem now which we can try to learn under our exhaustive search, that is knapsack problem. So later in the further classes we will be discussing the same problems now using the different techniques we are going to follow. The third and the last problem in this particular concept of exhaustive search is assignment problem, right? First let us understand now what do you mean by an assignment problem. Now this involves assigning n different jobs. Right? Now you have got some jobs are there, so I have to assign n different job to n different people. Say for example, now as a project manager, now in my team I have 5 members are there in my team. Now I have got one problem to solve it. Now I have to assign this problem. I will divide this problem and I can call it a job 1, job 2, job 3, job 4 and job 5, because there are 5 members in my team. Now I have to assign each job to individual members of my team in such a way that I should get this job to be done very fast, right? So because I have to execute this job very fast. How do I execute the job fast? I have to assign this job to these 5 people. But when I am assigning, I have to take care that which person is taking how much time to execute, right? If I give one job to an employee A, if he is taking 10 hours to execute that job, if the same job is given to some other employee or some other members of my team, if he can execute the same job in 5 hours, then I should not give this job to A, I should give it to B, because B does it fast. I should give some other job to A, right? Now this is what this particular assignment problem says. So you are supposed to assign n different jobs to n different people. Now there will be cost assigned for a job to a person. Now what is this cost? As I told, how much time, right? So if I assign job 1 to A, employee A, how much time he takes? The same job 1, if I apply, like say if I give the job 1 to A, if it takes 10 hours, if I assign the same job to B, he may take 8 hours, C may take 5 hours, D may take 15 hours. So there is some value, the cost is been assigned for every job, the cost is been given for us. Now when it is been there, now you have to organize your task. These jobs has to be given to each employee in such a way that the total time for execution of job should be very minimum for us. The total time should be minimum. That is what the problem definition of assignment problem says, right? So the cost incurred for assigning the ith person to the jth job is denoted as Cij. We define this in a matrix form. So what is the cost incurred? So the cost incurred for the ith person. So when you are assigning an ith person, you are assigning some jth job, how much time he takes, that is denoted as Cij, right? Where what is here I is the persons and j is the job. So for I is equal to 1 to n, j is equal to 1 to n. So totally you have got n jobs and n persons are available. So now how do you define this problem, assignment problem? Minimization. This is a minimization problem, right? So you have to take care that you are finishing your job with less time. You don't want your job to be taken for more number of hours. You want to see that you finish the job very fast. If you want to finish the job very fast, how you have to do it? When you are assigning this to your team members, you have to pick that particular member who is very fast in executing which job, right? So minimization. So this problem here can be stated as minimization summation I is equal to 1 to n. What is I here? I indicate the persons, right? So for n person and j job you are assigning, each job you are assigning to one person. So one job should be assigned to only one person here. That is another constraint. You cannot assign one person more number of jobs. If you have 5 jobs and 5 team members, each one job should be assigned to only one person. You cannot assign all 5 jobs to only one team member and make other 4 members to sleep. That is not a good way of executing the task, right? So only one person, one job has to be assigned. So summation for I is equal to 1 to n, summation for j is equal to 1 to n, C of ij, that is the cost, x of ij, x is the persons. So for each person, what is the cost? When you find the total of all those things, it should be minimum. It should be the minimum and subjected to constraint. Now what is the constraint for this particular problem? There are 2 constraints here. The first one is xij. Xij is equal to 1 or 0. That is, if ith person is assigned the jth job, that means what we are told, you can assign only one job, right? You are going to assign. See, once if you assign ith person a jth job, so then that job cannot be assigned to some other person. That cannot be assigned to some other person. And second constraint is summation for j is equal to 1 to n. That is, jobs of xij should be equal to 1. That means exactly one job is assigned to ith person, right? So this is the constraint what is there. So let us take an example and we will see how we are going to solve it by using exhaustive search. Now this is the assignment problem. Table is given for us. Now you can see here there are 4 jobs, J1, J2, J3 and J4. 4 jobs are there and 4 persons are there, P1, P2, P3 and P4. And this is the cost matrix. So cost matrix is C of ij. So what we told, now this is the, like say P1, for person P1, if you assign job J2, how much time is going to take? 10 units or 10 hours, for example, right? So he is going to take. So if the same job 2 is assigned to P2, person P2 is going to take 2 units of time. Similarly, same job 2, third person takes 15 units of time. So like this, for all each person and for all job, now it is given in a table. So this table we call it as a C of ij. For ith person, jth job, when you assign, what is the cost is been given for us. So now how do we start? So now the exhaustive search says that now we have to find all possible n tuples. Right? Now we are going to find all possible n tuples for the problem of n job. And we try to select the best optimal solution. What is that optimal solution? Which gives the minimum cost. So now we will start writing this. Now we will see that, so there are how many? There are 4 persons are there, P1, P2, P3, P4. Now you want to assign jobs to him, to these 4 persons, right? We will start our exhaustive search. Now first we will assign job 1 to P1. What we are doing? We are assigning job 1 to first person, second job we are assigning to second person, third job we are assigning to P3, that is third person, fourth job we are assigning to fourth person. Now when you assign first job 1 to P1, what is the cost? How much time he takes? You look into your cost matrix. Now job 1, see here, job 1 you are assigning to first person. Now if you look into your cost matrix, from cost matrix, so you have to get the value. So for first person P1, first job J1, how much time he takes? He takes 7 units of time. He takes 7 units of time. So we will write here 7, because when you assign the first job to first person, the total time he is going to take is 7. Similarly, second job you assign to P2. Second job if you assign to P2, how much is the time? Right? Now if you look into this matrix, so second job you are assigning to second person. So what is this value? 2. So you are going to get 2. So plus 7 plus 2. You want to find the minimum, right? So that's what minimum cost. So 7 plus 2. Similarly, when you assign third job to third person, from the table you can find the total cost is 4 units of time. Similarly, fourth job to fourth person, the total cost is 7 units of time. So when you find the total, it gives you that minimum total units of time is required. Now if you assign the jobs in this fashion, in this sequence, to all the people. Now we will take another possibility. Right? Now if you assign job 1 to P1, job 2 to P2, job 4 you are assigning to P3. Here we are exchanging, we are reversing these two. See, in the previous step, job 3 was assigned to third person. Now what you are doing, this job 3 is assigned to what? Fourth person. Job 3 is assigned to fourth person and job 4 is assigned to third person, and you find what will be the total cost. Similarly, now we are exchanging like this. Now you keep on shuffling all the possibilities, what all the various possibilities is available for us. Now like this we have to do all the possibilities for this. So now how many persons are there and how many jobs are there? N is equal to 4. So that means 4 permutation. Right? So n means n permutation. So 4 permutation means 24 possibilities we will be having. So 24 different permutations we get here. So like this, here as an example I have just written 1, 2, 3, 4, 5. So like this you will get totally how much? You will get 24 different tuples you are going to get. And for all these 24, like this you have to find the minimum cost. So minimum cost you have to generate. So once you derive like this minimum cost for all the 24 possibilities, permutations, out of these 24, which assignment gives you the minimum cost will be your final solution. Which assignment is going to give you the minimum cost is your final result. So now what you are supposed to do is that, so here just 1, 2, 3, 4, 5 tuples are there. Now remaining all the tuples you write it down for all the various combinations, permutations, and find the values, that is find the cost. And after that, when you look into the RHS, which combination, which permutation gives you the minimum cost, which assignment, how you assign these jobs, which jobs gives you the minimum cost. Now that will be your final problem. So now you can see in this example it takes so much of time for us, because there are 24 possibilities are there, not just 4, 5 or 8 like in our previous example. Now here you have got 24 possibilities are there, right? So you have to first write all the possibilities, and for which job, which person you are allotting, find the cost and find the total cost. Once you get all the total cost for all 24 assignments, out of that which is giving you the minimum cost, now that will be your final answer. So it takes lot of time. So when we are discussing this exhaustive search, that means when we are talking about the permutation, subset or combination problem, if you are using exhaustive search technique of brute force, under brute force technique only it comes, this exhaustive method. So it takes us lot of time. So for this example, that is travel assignment problem, so with n jobs, now the time complexity is n factorial, right? N permutation or n factorial. So you have got 4 jobs are there to be assigned to 4 persons. So the 4 factorial or a 4 permutation is 4 into 3 into 2 into 1, which is equal to 24. So the time complexity will be n permutation or n, right? So you can see that, so it takes lot of time, right? So these are the three very important and interesting problems which we have discussed in our exhaustive search. So now the same problems will be solved by using some other techniques, some other algorithmic techniques, because see, this is when we are using brute force and when you are using exhaustive search, it takes huge amount of time. So we have some other techniques are available which makes the algorithm to be very fast. We can design this algorithm in a still better manner. So those things we'll be trying to look it into our next classes, or when we go into the different algorithmic technique. So in this particular session, now we have discussed the 3 important problems. So under the exhaustive search, so what is that? The assignment problem, travel salesman problem, and knapsack problem, right? So this is about this particular concept. So I hope that it's very clear and you have understood. Still, if you have any problem in understanding, you can just drop a message in the classroom and Google. Thank you for listening to this particular session. Have a nice day.